Hi Kritos. So in this video we're going to check past papers for Euclidean geometry. So this is going to be a 2017 past paper. So this is November 2017. So I'm just going to solve the Euclidean geometry for you. Okay, so let's get started. Here we have this one, question 8. It started with question 8, and make sure that you understand this Euclidean geometry thing, because it's from question 8, question 9, question 10, and question 11. So if you understand the Euclidean geometry, you already passed. All right, so let's take a look at this one. In the diagram, points A, B, C, D, E lie on a circle. So let's check those points. Point A, B, D, C, all of them lie on the circle, with CE parallel to AB. CE is this one here, parallel to AB is this one here. We're shown that, and the same with E on AD produced. Okay, so we have E that is produced from AD. All right, so you can see that a chord CB and chord AD intersect at F. Whereas F is here, you can see where they intersect. D2 is given by 50, it's this one, and C1 is given by 15, right? So let's go to questions. They're saying calculate with a reason the size of A. So first we're looking for the size of A. Where's A? A. And secondly, we're looking for C2 and the size of C2. Okay, so in order to get this A, remember that we have to use, actually in this Euclidean geometry of grade 11 and grade 12, in most of the time they just want to check whether you still remember what you learned in grade 10, grade 9. Okay, so here we have this A, C, E parallel to A, B. So we have something like this. This here is C, this here is E, and here we have A, here we have B. So these two lines are parallel. So they can't just give you these two lines and say they are parallel while you don't have to use them. So you have to use them. Okay, so if you are using these two lines, that means this angle here, which is angle E, is going to be same as this angle here, using the alternating angles. So these two angles are the same, which forms the Z shape if these two lines are parallel. So these two angles are the same. So in order to find this angle A, first what we can do, we can just find this angle E here. So after finding the angle E, it's where we can find this angle A. All right, so first we have this angle 50 here and 15. We are given two angles, so you must know how can you find this E using these angles that you are given. And remember that in grade 9 you learned about this So if you have a triangle A, B, C, and this is angle C1, this is angle C2, so we learned that C2 is going to be angle A plus angle B, which is the angle of a triangle is equal to the sum of opposite interior angles. All right, so this is the interior angle and this is the interior angle. This is a theorem that we learned in grade 9. Okay, exterior angle of a triangle is equal to the sum of opposite interior angles. So these angles are the same. This big angle here is equal to the sum of these opposite interior angles. So therefore we can find that E. We can say that E is given by, to find A, we can say that E is given by, we have 50 minus 15, and which this is going to give us 35. And the reason we're going to give this is exterior angle of triangle. Which triangle are you talking about? Triangle DEC. Triangle DEC. All right, so this is what you are going to say. And if you move on to find this angle here, this angle C2, oh sorry, before we can do that, we haven't found the angle A. So since we can just conclude by saying also angle A is going to be given by, we already know what's angle A. So angle A is going to be 35 also. The reason we're using the alternating angle, so I'll just write alt angles. Yeah, the reason the alternating is because we have two things that are parallel to it. So we have C, since CE is parallel to, so you're done. So let's go to this angle C2. Where C2 is located? C2 is located here. So let's check how can we find C2. So C2, do you see that this is A1 and this C2, they are produced from this segment here. So let me erase this. So this, you learn this in grade 11. You learn this in grade 11. So this produce this angle here, which is angle A, and also produce this angle here, this one, which is angle C2. So what can you conclude? Therefore A1 and C2 are the same. So C2 is going to be 35 also. So it's 35. The reason you are saying is 35 is why the angle subtended by the same segment. In the same segment, angles in the same segment, same segment. See, they're coming from here, from this from this B, D, right? So let's move on. Let's move on to the next one. Here actually we'll just collect the free marks. And then we have this one here, which is 8.2. It says prove with a reason that CF is a tangent to the circle passing through points C, D, and E. CF, where's CF? CF, okay, this is the CF, is the tangent to the circle passing through point C, D, and E. Point C, D, and where's E? And E. Alright, so C, D, and E. EF. Okay, sorry. EF is here. Our EF. This is EF. Our CF, sorry. This is CF, and this is the circle that they're talking about. So we have a certain circle here, circle like this. So it's going to be a perfect circle. So you have to prove that this is a circle. This is the tangent to that circle. So actually, most of the time, we are proving that something is a tangent using the Tomcod theorem. So if you can use the Tomcod theorem, you can see that here. Do you see that? Let me erase this. We have this here. So if this, it's a tangent. So what's going to happen? If this is a tangent to the circle passing through here, that means this angle here must be equal to this angle here. We're using the Tomcod theorem. So the Tomcod theorem, remember, that states that if you have this and you have a triangle like this one and you have a tangent here, so let me draw a perfect circle. if you have this and you have this and you have this tangent here. Okay, I think this is perfect. So it says that this angle here is going to be equal to this angle here. Tomcod theorem. This is the Tomcod theorem. So therefore this angle here is going to be equal to that angle. So if these two angles are equal, therefore we say that okay, CF is a tangent. So the same proof with a reason that okay, so we can say C2 is equal to angle E. We proved that where C2 is here 35 and angle E, we should angle E is 35 also. So if you saying that therefore CF is a tangent, is a tangent to circle that pass through CDE. Using the Tomcod theorem. You are using Tomcod theorem. Alright. So these are the just things, and then you collect your 7 marks. Alright, okay. So I'm just going to do question 9. Okay, so stay tuned and keep watching.